Hello, my name is Kizito Odhiambo, and I will be presenting today on our project, the Geographical Information System for Sustainable Agriculture in Kenya and beyond. This is a project that is being led by Boniface Akuku from the Kenya Agricultural and Livestock Research Organization. With our project, we are trying to address the challenge of, on the one hand, we are seeing there is a lot of agricultural research data available in Kenya, but we lack accurate and timely satellite Earth observation data, and looking at how we can be able to integrate this satellite data with already existing research information, specifically to generate decision-making or to support decision-making for stakeholders within the agriculture ecosystem. Of course, looking at this from the perspective of also weather and climate variance, which is increasing the risk of the agricultural sector per se. So we are looking at how do we enable the agricultural sector to make better decisions, leveraging on the already existing local content from research on the ground, and also putting in the information that is coming in through Earth observation data, where we lack capacity of including this into already existing working processes. And our solution for this within this project has been to look at how we can be able to build a system that enables us to use this space-based data and agricultural data from the ground to be able to support decision-making for not only farmers but also other actors in the sector, from policy makers to industry. Looking, for example, at the challenges of smallholder farmers, we are looking at, on the one hand, questions about where to grow, what to grow, based on their location and the agroecological information. And this is information that has already been developed for different areas. We have suitability maps, but trying to understand how the current situation is the current season is progressing has been a challenge, because you need to now leave the research data and look at if you're able to obtain observed information. So we are hoping through this project to basically provide a decision support system for different stakeholders, where they're able to answer some of the questions relating to observed information or now monitoring activities. Where did it rain? How much? Or which sections of the country need interventions, for example. So during this project, we started by looking at how we can be able to set up the Send2Agri system. And the Send2Agri software basically was to provide us an opportunity to monitor crop development during the season with services such as dynamic cropland masking just after planting, at the middle of the season, and then at the end of the season, to understand what varieties of crops have been grown within the country, to also be able to determine the crop type map and identify the vegetation status of the crops. We had initial challenges setting up the Send2Agri system, so we resorted to trying out the Open Data Cube technology, which is an open source technology used to basically store and also retrieve satellite data for area of interest. So we have configured and deployed an Open Data Cube for Kenya to be able to analyze satellite data, especially from Sentinel-1 and Sentinel-2. And going with that is a Jupyter Hub environment, which is basically a coding environment, which we are using to develop algorithms, especially looking at crop phenology. Now, to be able to capture as well data from the ground, we have been doing geotagging activities with smallholder farmers using feature phones, which means we are not relying on internet, we're not relying on farmers having smartphones. And this is because most of the farmers still have feature phones. Some have smartphones, but access to internet is still limited. And with this technology, we have a GPS device which has a SIM card inside and a 3-meter accurate sensor. And a farmer can basically send an SMS to a designated number, and we are able to retrieve, or we're able to ping that GPS device and retrieve the position of the farmer and the field. And now based on that, we are able to demarcate the field boundaries and then run an object-based kind of analysis of vegetation and the indices that we want to generate through that, and also are able to send information to farmers, especially weather information, through our existing system within Calro. We have also initiated activities to collect information from farmers, so enabling farmer surveys that support us to get self-reported data from farmers. This is important to us because it helps us to identify planting dates, crop types, and such kind of information. And it has also proved very beneficial to us in collecting information about the impact of desert locusts, especially during the long rain period, March, April, and May of last year. We are now looking at how to use this data that we are collecting from farmers and the data that we're able to analyze from satellite data with the already existing agricultural research information to be able to develop models that support us to look at the water requirement satisfaction, and also looking at crop models to help us do yield prediction. Some of the challenges that we've been facing, I had mentioned before, are the limitation of not being able to set up the Send2Agri server, because we find that is a very good starting point to be able to look at how to maybe also improve the already existing algorithms within the Send2Agri system, and we'd want to look at how we can be able to still go ahead to deploy the Send2Agri system on our server for testing. On the other hand, we wanted to reach out to more users of such systems, decision makers from across the industry, from policy makers to private sector companies, to find out about how they want to interact with such kind of a tool. So due to COVID-19 limitations, this affected our movement in the course of last year mainly. And because we are capturing field information, we have had challenges in doing automatic field delineation. So we would want to look at how to obtain expertise that can support automatic field delineation, which is quite a challenge for smallholder farmers. And this can help us basically to analyze better what is growing the crops and also look at yield potentials. Looking at going forward, we want to geotag another 1,000 farmers to help us have good data that can be used within our models to understand the kind of decisions that need to be made that need us to basically do the interoperability of field data or research data and data from Earth observation, and also looking at how we can set up a web application for this. We're looking at this as an opportunity to basically improve the ground truthing opportunities for what we have available, and also supporting policymakers to make decisions based on not only research data that is available, but also on Earth observation data. Thank you very much.